We'll now move on to Peter Hayman. Peter is here somewhere. I've just got the wrong thing there. Come on, unmute. I'm trying to unmute you, Peter. Just doesn't want to work. Right, now we've got you on. Now I've got you unmuted. Yes. Now I'd like to welcome Peter. Peter works at SARDI, which is the Research Institute in South Australia. He's had a long history in water matters. I should stress, not political water matters though, just the physical aspects. So we won't be taking questions on the Murray-Darling Basin because it's kind of irrelevant to this discussion. But we will be prepared to discuss anything to do with the impact of climate change on how much water you might get in your rivers and the physical aspects. I hope that clarifies things for everybody. Now, Peter's given a number of talks across the country and they've always been very interesting. One I saw in Wagga, and I imagine you'll cover that today. So without further ado, I'll hand over to Peter. Are you there, Peter?
Yeah, I'll try and share my screen.
Well, you may be able to. I've been trying to get... are you there, Fiona? Can you make Peter a...
So I have host disabled participant screen sharing.
Yeah. Are you there, Fiona?
I have just enabled the co-host. Sorry
Thank you.
about that.
So share. Okay, so can people see my PowerPoint slide there?
Impact of climate change and climate variability on river inflows and water availability.
Fantastic. Okay, so thank you very much for this opportunity. You know, I really want to make it really clear how pleasing it is to, firstly, be part of Farmers for Climate Action, to join with you in this, but also, I guess, to follow a psychologist on this discussion. I think it's really important that we acknowledge these are environmental issues, there's economic issues and so on, but in the end, it's people issues, and we really want to. I think it's really good to have that emphasis. So I've just got a slide here that is, I guess, making this point that it would be nice to be able to say this is exactly what will happen at a local scale with a changing climate. I do have a little bit of information on that, but in the end, I think a more important point is the eminent climate scientist Wally Broker makes a point: the climate system is an angry beast and we're poking it with sticks. Ross Garnaut made this point that basically we don't know what's going to happen, and that's why we need to reduce emissions, because we are going into deep uncertainty about how things will happen. We know that we are changing the radiative properties of the atmosphere. What that will do to rainfall in southern Australia is worrying, but remains uncertain. We know there are physics that tell us that less rainfall has a magnified effect on runoff and the seasonality of that rainfall and so on. So it's not a case where we don't know anything about the future, but a key point is that we need to be cautious about saying it will be exactly 11.3% reduction or something like this. There's a danger in false precision and uncertainty in this area. So I'm saying we need an adult, respectful conversation, and Wendy opened this by saying this is about a conversation. I think we do need humility. We don't know everything, and that's actually a good place to start, that we're standing together with an uncertain future here. We need to be clear about the confidence and the uncertainty. There's some things that we do know about the fact that we're changing the radiative properties of the atmosphere, that will change temperature, and that will change rainfall and runoff. And we can have some aspects of understanding that, but we need to be careful about being overconfident on things that we're uncertain about in this adult respectful conversation. I think we need to acknowledge the variability of the past, and that especially with rural communities who've deeply lived through year by year, decade by decade variability, sometimes the conversation is as if with a computer model about the future, that trashes all the past experience and deep learning from that and so on. So we need to acknowledge that variability of the past. I've also said there, and this is to be curious and apply skepticism to both the contrarian and the alarmist. I mean, people will call me an alarmist, but let's just say it's worth being curious and asking, why are people saying what they're saying? What's the evidence and so on? There's this nice line that we are naturally born lawyers, not scientists. Even those of us who have been trained in science, we tend to take a position and defend it on a whole lot of things. So we, and I guess a line in science is that the most important, this is Asimov said, the most important line in science isn't eureka as I found it. It's, that's interesting. Where something surprising, and we need to acknowledge that this remains a surprising area. And finally there I've got from that well-known climate scientist Tennyson, tread softly for you tread on my dreams. We need to recognize that we are talking at times about an existential threat, and the idea that we should just cajole people here. We need to be very aware that these are people's livelihoods, and especially in rural areas. And my sense is sometimes people are asking farmers to make major preemptive adaptation changes and so on, that I don't see those same people making in their own lives necessarily. So I think that this is an important part of the respectful conversation. Part of how I talk with with farmer friends about this, and some farmers who probably find it annoying having this discussion too. But what I say is, look, and this isn't my idea. This came from Stephen Schneider, who's a climate scientist, who had this point that you can have an argument with a child on the beach as to what destroyed the sandcastle. Was it the wave or the tide? And you go backwards and forwards and say it was the wave that did it, it was the tide that did it. It's always the wave that destroys the sandcastle. But on a rising tide, the wave does more damage. It's not a case of variability, year-to-year variability or individual weather events, which are the wave, and the long-term underlying trends in climate change, which is the tide. It's not a case of either or. And sometimes we have this sort of futile discussion after a bushfire or a drought of, was that climate change or was that natural variability, as if we can say it's either one or the other. Now, there's a very interesting science of detection and so on, but I think we need to be cautious about this notion of dividing this off into two separate things. These are two processes that are happening, and we need to acknowledge them together, and it's useful to have that notion. As a grape grower said to me, sometimes it's a dog that destroys the sandcastle. So there's other things like low grape prices and other issues that come along and affect you. On this issue, I think that it was really interesting having Gordon talk about the short-term aspects of a bushfire and the ramifications of that, a very intense disaster. Then there's drought, which is a slow-moving disaster, and that's complex. I guess I'm saying that we add to that complexity even more by adding the notion of aridity. So are we seeing a long-term drying rather than a drought? And that makes it even more complex because we've got these trends at different time scales, and how we think about that and how they interact together are inherently complex. If someone says, I'm leaving this rural community because of a drought, because I just am sick of dealing with drought, that's one thing. If somebody says, I'm leaving because of aridity, because of things are getting drier and drier, that's another message that they're sending behind, and how those messages go and how those go through the communication lines that Rob was talking about there, I think is an interesting and important point. So I have this quote, which I actually, again, I just collect these things from other people, but this quote came from Gabrielle Chan, who was talking at Birchip on a climate change and discussion, and she had this quote from Wendell Berry: "The only true and effective operator's manual for Spaceship Earth is not a book that any human will ever write. It is hundreds and thousands of local cultures." And so again, this reinforces my point that this is what I think is really good about Farmers for Climate Action and these local forums, is that this does need to be solved, and how we manage these things have to be solved locally in terms of adaptation. Also, how do we come across ways to reduce greenhouse gases in ways that are fair and equitable and effective? So there's this interesting challenge about what do we do at a local level, and this is a global problem as well. So that how do we manage that as well? So the Goulburn Broken catchment has this very a lot of work has gone into this, into working out vulnerability in different sub-regions and so on. I'm acknowledging this really important work. I'm not going to go through and just show you a whole lot of slides of that, but I would urge anybody to look at that. And if I'm looking at an out-of-date one here, I apologize greatly for that, but there's a lot of fantastic work that's gone in here, and a lot of community discussion and so on that's gone into this. But this is also a global issue. And I think an important point to just quickly remind ourselves is that this is a global issue, and we're talking about a mature science. So be cautious about somebody like me, or I'm an agricultural scientist who works in climate applications, or a climate scientist who comes along and says, I've got this radically new information. To an extent, when Thomas Brokaw came and spoke at the Greenhouse Conference, he's sort of saying this science is getting mature, in some ways, from a journalist perspective, boring. We know some of these things. We know we're warming the world, and we're repeating, more and more studies are repeating that. So basically what he's looking at there is a 2 degrees world and a 4.5 degrees world, greater warming at the poles, greater warming inland, and then quite concerning is this notion that a warmer world would be a wetter world. A warmer world would be a wetter world, except where, what I say in South Australia is a warmer world is a wetter world, except where you chose to inherit a farm or bought a farm. So the problem is that the drying in the mid-latitudes here. And so what we see here is that the darker colors are at the poles and the equator, but the mid-latitudes tend to show a drying. And that's something you can see to an extent with all the terrible fires in Australia, but also the fires in California, in Spain, in Mediterranean areas. There's this worrying drying happening across Mediterranean regions. And one of the concerns is that when you use the latest climate models, rather than being a sort of, oops, we overstated this, it's more of a concern that there might have been understated. So there may be more warming, and as these more climate models build in some of the feedbacks and so on. So again, just going back to this simple idea that how I find useful to think about this is the year-to-year variability versus the long-term changes, and that's really about short-term variability and drought versus a longer-term aridity, about a hot year versus warming. And I guess my simple point is that we have much more confidence about the hot years and the warming. For Southern Australia, the worrying aspect is, are we seeing aridity and drying? So here's the southern wet season. This is the winter season for southeastern Australia. And you can see there the millennium drought, and it's pretty dramatic. Perhaps what's more concerning is since the millennium drought, you can only see 2 blue bars. The first one is the La Nina of 2010-11, which was a dramatic ending of the millennium drought, followed by 2016 there, which was the Indian Ocean Dipole negative 2016. Now, there are some indications that 2020 will be another Indian Ocean Dipole negative year, and it would be wonderful if it was another blue line there. But even if it is, that's 3 blue lines since 2000, or the beginning, and even the 1990s, late 1990s. So this is of now a lot of dryland farmers who I interact with have done very well and adapted extremely well to these conditions. And some of these years are not that much drier than the long-term average. But obviously the concern about recharging river systems and so on, those blue bars are very important. So there's concern about this long-term drying across southern Australia. Now we don't, again, this is partly decadal variability, but it is consistent with some of those models, and it's consistent in a broad sense at a continental and global sense of that diagram that I showed that Thomas Stocker was looking at earlier. Going to the short-term variability, the Murray-Darling Basin drought update, this comes out regularly, that's updated fortnightly. It gives us information about what's happening. And you can see now that the southern basin is wetting up a bit. Although when I looked at this, I was surprised at just in some ways how these numbers are still pretty low in terms of the blue as how much is there, but also even just how much has increased since the last fortnight. Now, systems, you know, there's the outlook from the Bureau is mixed but pretty positive, and we would hope that those numbers would be going up. But this is about short-term variability, the wave, if you like, and I think there's really good information. The Bureau and the MDBA is doing a good job of communicating that and understanding where that is. This is the Indian Ocean Dipole, which is the interesting aspect that everybody has their eyes on. So so you can see there the Indian Ocean Dipole. Just as a quick sort of point, when the IOD is positive, that's bad for us generally, and when it's negative, it's good for us. When we were just talking about El Nino and the Southern Oscillation Index, it was easier because a positive SOI was good for us. You just have to sort of reverse that thinking, which is sometimes a little bit challenging. But you can see that what happens with a strongly positive Indian Ocean Dipole is that we tend to be cooler off Australia and warmer off Africa there, and you get floods in Africa and this drying and in Australia. Where we are at the moment is we're bouncing around, but the suggestion is that it's well worth watching, but the suggestion is we may be heading back to more like 2016, where that would be negative, which gives us warmer waters, and that has a better, much better outcome for us. There's also discussion about La Nina and so on. So there's a lot of information about the short term, this seasonal variability. I think there's work that's getting better and better at that information. It's far, far from perfect, but we're understanding some of the drivers. Now let's talk about the long term, the tide, going back to the tide. So this is an older report on the 6 main risks to Murray-Darling Basin water. Was climate change, large-scale tree planting. If we have lots of trees rather than pasture, they'll use more water. groundwater extraction, irrigation management, farm dams, and bushfires. Now, I won't go into these in too much detail, but they're interacting in interesting ways in terms of even if warmer conditions, forests and land use will use more water under those warmer conditions, higher CO2, they may even grow more at certain times and so on. It's a complicated story there. The groundwater extraction, just clearly, this is a complex and linked system. The irrigation management is an interesting one, and people following that is that, yes, it's true that we need to, irrigators are getting more and more efficient. Some of that inefficiency, where it's leaking back into the water table, is a loss to the irrigator, but it's not a loss to the system. Whereas irrigation water that's evaporated is effectively a loss to the whole system. But farm dams, a controversial aspect of where they are, and bushfires. One of the main costs of the Canberra bushfires was the impact on water, because new growth uses so much water. So these are complicated and interacting factors. The Murray-Darling Basin Plan has a climate change discussion paper, which is well worth reading. And what do they use as their sort of guidance on this is these two large studies, which were done quite a while ago. So the Murray-Darling Basin Sustainable Yield Study projected the average volume of available water could decline by 11% by 2030. There's a range between an increase or a very significant decrease. And then there was SIACI, which is a Southeast Australian Climate Initiative. Bureau of Meteorology and CSIRO did a lot of work here. And this is what they're quoting, is that 1% increase in the mean global temperature by 2030 could lead to changes in mean annual runoff, -2 to -22% in the Southern Basin, and a bigger range in the Northern Basin. I guess my point here is that these are big ranges. The outlook for the Southern Basin is worrying, but it's somewhere between I guess a minor reduction that could be picked up easily within efficiency and so on, and a major reduction. I guess what I say to groups that I'm talking to in irrigation is let's plan for a warmer and water constrained world. Trying to be over precise in exactly what's going to happen is going to be difficult, and I think that's underpinned by the fact that the uncertainty about rainfall. So just my quick understanding of what's happening in Shepparton, and obviously people from here are reading from other areas as well, but a very high emphasis on dairy, apples, horticulture, these high value crops, all of which are vulnerable and exposed to heat waves, to lack of water. This is from that report for the Murray-Darling Basin, is that increasing average temperature, increasing maximum temperature, increasing minimum temperature. I'll put a side note in there that we are getting, in some areas, more to the west of that region, there's this interesting aspect of increased frost numbers due to these dry springs. The number of hot days increasing. This worrying aspect of the cool season rainfall decreasing, the snowfall decreasing. That doesn't mean that there hasn't been lots of snow this year. Again, this is about waves and tides. The soil moisture is decreasing. That means that when we do get rain, we have a dry soil which absorbs that, and I think that's the ability to respond quickly. Evapotranspiration is increasing, although not the increase in evapotranspiration for a degree warming is not as huge as you might first think. So the difference between evapotranspiration on a 30-degree day and a 40-degree day is very substantial, or a 20 to 30 degrees, but we're not talking about 10 degrees. We're talking about 1 or 2 degrees in this initially, and the differences there are in the order of 4 to 5, 8%. Runoff decreasing, and that's the worrying aspect, that that as these other factors compound on a decrease in runoff. Extreme intensity of rainfall increasing, time of drought increasing, and frequency of severe drought increasing. So clearly these different metrics are not going the right way on the whole. So one way of thinking about future climates is that we get the climate change projections from the global climate models, and we run that through crop models and dairy farm system models. And it's been really interesting and important work done on that. And I've been involved with some of that with cropping models and so on. So that's this first one of the climate change projections. We can also do this sort of sensitivity analysis of how would the system handle stress testing. So how will we stress, how will we handle 1.5, 2 degrees warming, or different levels of rainfall decline? And I think that's a useful exercise to actually try and look at, given some of the deep uncertainty here, to look at some of how we just handle some of these changes and so on. Then I think there's this idea of temporal analogs, the drought and the spatial analogs. And so what I've called this is these 4 aspects of thinking about the future. We can model the future, and we've done that. We can play with the future or stress test the future. So if you like, this vertical axis is more numerical, and it's looking at that way. But we can also remember the future. So how do we handle the drought? What have we learned from that? And we can visit the future. That is, what are areas that are warmer and drier than where we are, warmer and more arid than where we are? So this is again from the Victoria work, which is based on CSIRO work, is that in 2050, under high emissions, the climate of Shepparton will be more like the climate of Griffith now, and Wangaratta and Benalla more like Dubbo. So you're basically using this idea, there's a tool you can use to look at how you may change in those ways. And clearly, there's agriculture at Griffith, but it's different to the agriculture at Shepparton. And there's also important differences between the two as well. So we know we're getting warmer average temperatures. We have very high confidence in that. These extreme heat events, there's high confidence in that. The change in frost frequency and intensity, there's lower confidence in that in the coming decades because of this interaction with drier springs and so on. The change in seasonal rainfall is so vital and so important to this discussion, but the confidence in that is moderate. It's worrying but uncertain. The changes to the intensity of rainfall, there's higher confidence in that. This is just basic physics, that a warmer world, you have a more intense hydrological cycle. And higher levels of CO2, very high confidence, we're certain about that. So these first ones, the very high confidence, if you like, the first order factors, and then these other ones are a little bit more, there's a weather and a climate component. So how heat frequencies, frost and seasonal rainfall, there's less confidence because, if you like, they're a second order factor on this. So one way to think about this is that heat waves have both a climate component and a weather component. The climate component, we know the inland of Australia is much hotter. The weather component is, when do we get those blocked high pressure systems that will block in the Tasman and bring those heat waves down? And that's less clear than the actual understanding of the initial warmth. So I want to finish by talking again through this really important point of what's happening with rainfall. Again, the trends are worrying. The trends are noisy. The trends are short-term there. We don't just extrapolate the trends, but looking at those trends of what's happened since the millennium drought is concerning. So these are different models run for these systems. And basically, the white bar in the middle is if there's very little change, -5 to +5%. And you can see that for the general broad region of which Shepparton is part, that look at the annual one over to the right there, is that that say 25 of the models, of the 70 models, or a bit over 25, are saying plus or minus 5%. But there's a skew to the dry side. So very few models are going for a significant wetting. Now that's for annual. You can see for summer rainfall, it's more variable, autumn, but winter and spring, there's this stronger skew to the drier side. So one way to look at this is like a pipe, like a wheel that we spin. We have, if we were saying that climate change has no impact on rainfall, we'd say that we just spin this wheel, and we might say that we have a strong chance of it just being -5 to +5. Of course, because of decadal variability in the coming decades, it might get wetter, it might get drier, it might get a lot wetter, it might get a lot drier, but it's most likely to stay in that sort of range. So we just spin this wheel and we have equal chance of this happening. What this report is saying is that the pattern on the wheel has changed. When we spin the wheel for September, October, November there, that's quite worrying, because we're actually swinging that around to a much greater chance of a decline. We don't know exactly where it will land, but the concern is of the 70 models that most of them are leaning towards the drier side in that time. Again, there's uncertainty here. We may be lucky, and it might be that it doesn't end up there, but we don't know that. One of the concerns, and this was an interesting article that Professor Matthew England had after the bushfire season, that the models of variability, so that's IOD and southern annular mode, are not changing in a way that's good for Southeast Australia. We are stacking the dice for the chances of these extreme drought years because of the changes in these modes. So it's not, what he's saying is that this sort of second, third order interaction of how we're changing things seem to be affecting the IOD and the southern annular mode in a way that's not as helpful. In terms of El Nino, which is a major and the major driver, the evidence there, as I would understand it, is more that there may be more intense La Ninas and El Ninos. Another worry is that Michael Gross et al. In 2017 assessed those 70 models, so that those wheels I showed you and those diagrams based on the 70 models, and they used the 15 models that best represented the rain-bearing circulation for Southern Australia. These 15 models showed a stronger drying, especially in the winter. So again, I'm saying there's a lot of uncertainty here, but I'm trying to take it through to the argument as to why this is quite concerning, because the models that seem to represent things better are showing that, so showing more drying. So there's my sort of quotable quote from Wendell Berry, that the only manual for Spaceship Earth, these challenges, is the hundreds of thousands of local cultures. And I think it's really important that we respect the indigenous culture of the region, the the multicultural cultures of the region, the many complexities that Gordon drew in his diagram and so on there. How we interact with them in a discussion about this global aspect of climate change is a significant challenge, but I think a really good starting point is coming at that from a group like Farmers for Climate Action, because of the grassroots aspect and so on. So I'll leave it there. Thank you.
Thank you, Peter. That's probably not as uplifting as we might like, but it's pretty important information, and it's really interesting, that quote that you had about the adaptation being local, which is exactly what we're trying to achieve here, is explain that to people that, as Rob Gordon explained, they need to form community groups and keep communicating to try and work their way through some of these pretty intricate problems.